Hi everyone. So last lesson we looked at the constant acceleration formulae and we looked at deriving these formulae, and today what we're going to do, we're going to use these in various questions or initial examples of this topic. Okay. One thing to note then before we get going on the examples is this: the most common situation of this constant acceleration is motion under gravity. Okay, so the force of gravity pulling things down towards the earth. Okay, and the acceleration due to gravity, which we denote as g, we're going to take that in maths A level as 9.8 meters per second squared. Okay, unless they tell you to keep g in the question, or they tell you to take g and round it to 10 or something, this is our default, 9.8. Those of you that do physics might use 9.81 in physics questions, but in maths questions, they just want you to use it to 2SF like this. They just want you to use it as 9.8. And as I say, the force of gravity is acting downwards. So the acceleration due to gravity is going to be acting downwards, down towards the earth. And that's going to be important when we look at questions in a second. Okay, so let's get looking at a few of these questions to start this topic off. Let me just get a piece of paper. So our first question: a cyclist accelerates uniformly at 1.5 meters per second squared. If his initial velocity is 3 meters per second, find how far he travels, so displacement here, in 8 seconds. And again, part B, another displacement, how far he travels before reaching a speed of 7 meters per second. And when we're doing these questions, we're always going to start off by writing SUVAC down. Okay, so writing those initials down. We're going to fill in then the things that we know, and then that's going to help us choose which of these equations we need to find our unknown. Okay, so looking in this question, what have we got? We've got uniform acceleration, 1.5. We've got initial velocity, so that's our u value of 3. And for part A, we're asked to find how far he travels, so that's what we want, our displacement, in 8 seconds, so t is 8. So V, I don't know, and I don't want to know, so I'm not bothered about that. So we look at these, taking V out of it, we've got S, U, A, and T. And the more of these that you do, the quicker you'll get at choosing the right equation. But what have I got? S, U, A, and T, I want that involved, so that's going to be this equation here. So always have these equations in front of you, and as I think I said in the notes, they are given on the formula booklet in the exam as well, so you don't need to learn them, but the more you use them, the quicker you'll get. S equals ut plus a half at squared. Let's substitute in. U is 3, t is 8, a half, 1.5 for acceleration, and then 8 squared. And if you sort that out on your calculators, you should get 72 meters. Okay, part B. S-U-V-A-T. So again, let's have a look here. How far he travels in 8 seconds was the first question. Second question, then t is not the same. So how far he travels before reaching a speed of 7 meters per second. So how far he travels, displacement is what we want to know. Our u was still 3 because that's what we started at. Our v now, we want our final speed for this little section to be 7, and our acceleration is still that constant acceleration before. So here, S, U, V, and A. I don't know t and I don't want to know it, so S, U, V, and A is going to be this equation. V squared equals U squared plus 2AS. Substitute in, so V squared, 49, is U squared, 9, plus 2. Acceleration is 1.5. And S, that's an S, not 5. S is what I'm trying to work out. And if you go through this, you should, and I'm expecting you to do that, please, you should get S is 40 over 3. So 13.3 recurring, 13.3 meters to 3SF. Okay, and that's question 1 done. So let's keep going with this. Let's have a look at question 2. I'm just going to move this up. So question 2 now. Let's have a look at this one. So question 2, a stone is thrown vertically upwards. So this is going to involve gravity because we're throwing something vertically upwards. So here, this is going to be really important that our acceleration due to gravity is going to be our 9.8 here. Okay, so let's have a think about this question. And if we just sort of draw a little bit of a diagram. So it's thrown, here's this stone, it's thrown vertically upwards It's going to go up and come down. That's what's going to happen. So I'm throwing vertically upwards. And it's thrown vertically upwards with a speed of 28 metres per second. So that's what's happening in that upwards direction. Okay? And there isn't actually very much information in this question. Sometimes people do this and go, well, I only know one thing, how am I going to do this question? But let's have a think about what we know. The other thing in these questions that's really important is that we tell the examiner which direction we're taking as positive, whether we're going up as positive, so then U is going up, so that's positive, or whether we're going down as positive, and if we did that, then this would be negative 28 because it's going against the flow. So I'm going to take up as positive because that's what I'm doing. I'm throwing this vertically upwards, but tell the examiner that that's what you're doing. So all of my values in this, I'm going to have to remember to reference them to up being positive. Okay, so let's have a look at SUVAT. Let's think about what we know and what we want to know. So we want to know the time taken. So this is what I want. I want to know the time that's taken. Okay. What do I know? I know U is 28. Now, do I know anything else? Because obviously I need to know 3 other values to find the fourth value in any of these. So at the minute, I haven't got enough information. But I do know the acceleration because once this thing's going, the only force that's acting is gravity. Once it's let go, then all that's happening is the gravitational force pulling it back down to Earth. It's going up first, but then it's coming down. So it's going to decelerate, it's going to slow down on the way up, not decelerate. It's going to slow down on the way up. The velocity is going to get less and less and less up to this point, and then it's going to come back down. And so actually at this point here at the top, we'll know something about that as well. But let's put acceleration in first of all. Now acceleration, it's going to be minus 9.8. Why is that? Because I'm taking up as positive and acceleration is acting downwards. So definitely minus 9.8. Still haven't got enough information to be able to find T. But what else do I know? At this point here then, at the top of the motion, at the greatest height reached, my velocity is going to be 0. And let's just think about this. So as this goes up, so if you imagine it's going up and up and up, slowing down, and just for that instant, instantaneously at rest, it's going to stop there just for an instant. And you would only see it if you slowed your camera video right down. It gets up to that point, then it stops just instantaneously, and then it comes back down. So the velocity is reducing, stops, come back down, reducing, and we don't see it, do we? It's all continuous motion, but it is instantaneously at that top point, the velocity's gone from being positive and slowing down to then being negative, speeding up, coming back down. So up, velocity is 0 at that maximum height, comes back down. So that's really important, and that happens at the greatest height reached. Okay, and that's something that comes up a lot in questions. Okay, S I don't know and I'm not bothered about, so let's do this. We will want to find S in the next bit, but to begin with, let's find the time taken. So U, V, A and T, it's going to be this equation, V equals U plus AT. Let's substitute in. Let's rearrange that. So that's going to give us 2.85, etc. on your calculator. So 2.86 seconds to 3SF. Okay. Next part says find the height. So there's part A done. Part B, if I can call it that. Let's have another look. So this time I want my displacement. I want the actual height. U is 28. V is 0 at that top point, which is what I want because I want to know this height here, this displacement. So that's minus 9.8. Now T I could put in, so in another question you might have to use this. I'm not going to use this because what if I'd made a mistake here? So if you don't have to use something you've just worked out, then don't. But I could definitely use this and it would definitely still work. I'm going to use these for though, S, U, V and A. So I'm going to be using V squared equals U squared plus 2AS. Substitute in, so V is 0, so 0 squared is 28 squared, 2 times minus 9.8, because I'm taking up as positive, times my S, which is what I'm trying to work out again here. So rearranging this, 28 squared, sorry, that's going to be positive when I bring that over. And again, you should get, if you type that in, you should get 40 metres, and that works out as a nice exact answer. You would get the same answer here if we used t here. So if we used t to find s, and then, I don't know, maybe used s equals ut plus a half at squared. So do try it, but you will only get 40 if you use this full value. You mustn't use the rounded value. If you use this full value and you use this, then you will get s is 40 again for this question. So there's our first two initial examples. I'm going to stop the video. Do take your time to have a look at that. Make some notes on these as well, please. And then we'll do the next three examples in the next video.